Implementation of advanced weaponry systems by 2025. Date: January 27, 2025. Budget allocation: $3.2 billion. Focus areas: cyber, air, and naval integration. Executive summary. The implementation of advanced weaponry systems by 2025 marks a significant strategic initiative aimed at enhancing military capabilities through a structured approach involving a $3.2 billion budget. This initiative focuses on integrating cyber, air, and naval systems across four key phases: research and development, R&D, testing and evaluation, integration and deployment, and operational readiness and maintenance. Each phase is crucial for ensuring that the military can effectively respond to evolving threats in a complex global landscape. Key phases of implementation. 1. Research and development, R&D. Objective: identify technological needs and develop prototypes for advanced weaponry systems. Investments: allocate funding towards artificial intelligence, AI, machine learning, and sensor technologies to enhance decision-making and operational effectiveness. Outcome: develop prototypes that showcase innovative capabilities and address current military challenges. 2. Testing and evaluation. Objective: conduct rigorous testing of developed systems to assess performance and reliability. Methods: utilize simulations and field tests to validate technologies under various operational conditions. Outcome: ensure that all systems meet stringent performance criteria before integration into active military operations. 3. Integration and deployment. Objective: seamlessly integrate new systems into existing military frameworks. Focus: ensure compatibility with current platforms and provide training for personnel to operate advanced systems effectively. Cybersecurity emphasis: protect and secure weaponry from potential cyber threats, ensuring resilience against digital attacks. Outcome: achieve a cohesive operational capability across air, land, and sea forces. 4. Operational readiness and maintenance. Objective: establish protocols for ongoing maintenance and operational readiness of advanced weaponry systems. Continuous monitoring: implement systems for monitoring performance and initiating upgrades as necessary. Outcome: maintain the effectiveness of weapons systems against evolving threats, ensuring long-term strategic advantages. Budget allocation. The $3.2 billion budget is strategically allocated across the four key phases, targeting essential areas of development. R&D: significant investment in emerging technologies, particularly in AI and sensor technology. Testing: resources allocated for comprehensive testing protocols to validate system performance. Integration: funding directed toward training programs and cybersecurity measures. Maintenance: allocations for ongoing operational support and system upgrades. Common key points. 1. Interoperability. A critical aspect of the initiative is ensuring interoperability among various military branches. Advanced systems must function cohesively across air, land, and sea to enhance overall effectiveness. 2. Cybersecurity. The initiative places a strong emphasis on cybersecurity, recognizing that modern warfare is increasingly threatened by cyber attacks. Safeguarding advanced weaponry is paramount. 3. Innovation and adaptation. Continuous innovation is emphasized across all phases to adapt to new technologies and emerging threats effectively. Differences between sources. Despite a general consensus on the key phases and budget allocation, variations exist regarding specific technological focuses. For instance, some sources emphasize drone technology while others highlight the importance of cyber defense systems. Additionally, proposed timelines for each phase differ, with some advocating for accelerated schedules to address immediate security concerns. Complete timeline of events. 2023, initial funding and strategic planning for R&D commence, setting the stage for future advancements. 2024, prototypes are developed and preliminary testing begins, laying the groundwork for comprehensive evaluations. 2025, full-scale testing and evaluation of systems occur with integration into military operations starting towards the end of the year. 2026, achieve operational readiness. With ongoing maintenance and system updates planned to ensure adaptability to new threats. Conclusion. The implementation of advanced weaponry systems by 2025 is a multifaceted initiative requiring careful planning, substantial investment, and a focus on integration across military domains. By emphasizing R&D, rigorous testing, and effective integration, the military aims to enhance national defense capabilities in an increasingly complex global environment. The collaboration among various technological sectors will be crucial for achieving operational superiority in future military engagements. The implementation of advanced weaponry systems by 2025 as outlined in the strategic initiative with a $3.2 billion budget reveals several counterintuitive aspects worth noting. 1. Emphasis on cybersecurity over traditional warfare strategies. While one might expect a military initiative focused on advanced weaponry to prioritize conventional arms development, the substantial budget allocation for cybersecurity indicates a shift in focus. This could be surprising given that traditional views of warfare often emphasize physical armaments over digital security measures. The recognition that cyber threats can undermine military effectiveness suggests a paradigm shift where the virtual battleground is considered just as critical as the physical one. 2. Interoperability might complicate development. The emphasis on interoperability across different military branches is crucial for the effectiveness of integrated weaponry systems. However, this can lead to counterintuitive complications in the development process. The desire for seamless operation across air, land, and sea platforms may necessitate compromises in individual system performance. This could lead to scenarios where systems are less optimized for specific environments because they must also function within a broader integrated context, contradicting the traditional approach of optimizing for specific operational domains. 3. Prototyping phase could consume unexpected resources. The R&D phase, typically seen as a preliminary step requiring a modest budget, may absorb a larger portion of the funding than anticipated. The complexities involved in developing advanced technologies such as AI and sensor systems can lead to unforeseen challenges requiring additional resources and time. This counters the common assumption that the later phases of testing and deployment are typically the most resource-intensive. 4. Rapid technological changes may render systems obsolete. The plan's timeline suggests that by 2025 systems will be ready for operational use, however, in a rapidly evolving technological landscape. The systems developed may quickly become outdated. This highlights a counterintuitive risk where the pace of technological advancement outstrips the military's ability to integrate and deploy new systems efficiently. Investments made today could lead to capabilities that are already behind the curve by the time they are operational. 5. Maintenance protocols may be overlooked initially. The final phase emphasizes operational readiness and maintenance, but initial planning may not adequately account for long-term maintenance needs. This could lead to an overestimation of the system's viability and reliability in the field, particularly if the systems are highly sophisticated and require specialized knowledge for upkeep. The assumption that advanced systems will operate effectively without a robust maintenance framework might lead to unexpected challenges down the line. 6. Artificial intelligence's role could lead to ethical dilemmas. Investing heavily in AI and machine learning for military applications may lead to counterintuitive ethical dilemmas, particularly concerning autonomous weapons systems. As AI capabilities become more advanced, the potential for autonomous decision-making in combat scenarios raises questions about accountability and the moral implications of delegating life and death decisions to machines. This aspect may not be fully addressed in the initial phases of implementation, leading to future conflicts over the ethical use of such technologies. 7. The collaboration across sectors could slow innovation. While collaboration among different technological sectors is deemed essential for enhancing national defense capabilities, it may inadvertently slow down the innovation process. The need for consensus and alignment among various stakeholders can lead to bureaucratic delays and hinder rapid advancements. This counterintuitive outcome suggests that while collaboration is necessary, it may not always result in the swift progress expected in developing cutting-edge technologies. 8. Budget allocation challenges. The clear allocation of the $3.2 billion budget across the 4 phases may imply a straightforward financial strategy, however, this could be misleading. Real-world financial management in large-scale military projects often encounters unexpected costs and misallocations. As the project progresses, certain phases may require more funding than initially planned, potentially leading to funding shortfalls in other critical areas contrary to the initial budgetary assumptions. 9. Public perception and transparency issues. The initiative's reliance on high-tech systems and substantial budget allocations may lead to public skepticism regarding military spending. This counterintuitive outcome suggests that while the military aims to enhance capabilities, the public may perceive such initiatives as wasteful or misaligned with national priorities, potentially leading to calls for greater transparency and accountability. 10. The role of international relations. Lastly, the focus on advanced weaponry may not be solely about enhancing national defense capabilities but also about positioning in international relations. The counterintuitive realization here is that the development of these systems could provoke arms races or escalations in geopolitical tensions which the strategic planners may not fully anticipate. This could counteract the intended purpose of ensuring national security, leading to a more volatile global environment. In conclusion, while the implementation of advanced weaponry systems by 2025 is a comprehensive initiative aimed at enhancing military capabilities, various counterintuitive factors may influence its success and effectiveness. From cybersecurity priorities to the complexities of interoperability and the ethical implications of AI. These aspects warrant careful consideration as the military navigates the challenges of modern warfare in a rapidly evolving technological landscape. Overlooked content and its significance. 1. Long-term sustainability and lifecycle management. While the report outlines the critical phases of implementation for advanced weaponry systems, it largely glosses over the importance of long-term sustainability and lifecycle management of these systems. This aspect is significant because the military operates in an environment where rapid technological advancements can render systems obsolete quickly. A comprehensive plan that includes lifecycle management, addressing maintenance upgrades and eventual decommissioning, is crucial for ensuring that the investments made today continue to provide value over time. Failure to integrate lifecycle considerations could lead to wasted resources and capabilities that do not meet future operational needs. 2. Interoperability challenges. The mention of interoperability is a common thread. Yet the specific challenges associated with achieving it are often understated. The integration of cyber, air, and naval capabilities involves not only technical compatibility but also procedural and cultural alignment among different military branches. Each branch has its own operational protocols, communication systems, and strategic priorities. The significance lies in understanding that without a concerted effort to address these differences, the advanced systems may not function effectively in a joint operation context. The potential for miscommunication or operational delays during critical scenarios could severely undermine military effectiveness. 3. Impact of emerging technologies. The report emphasizes advanced technologies like AI and machine learning, but it does not thoroughly explore how emerging technologies such as quantum computing, autonomous systems, and advanced materials will shape weaponry systems. These technologies could provide significant advantages in terms of speed, efficiency, and capability enhancement. The significance of this lies in the potential for these technologies to disrupt traditional military strategies and operational paradigms. Military planners must remain vigilant about the rapid pace of technological advancement and its implications for future conflicts. 4. Cybersecurity beyond integration. Although cybersecurity is highlighted as a key component of weaponry integration, the report fails to address the ongoing nature of cyber threats and the need for adaptive cybersecurity strategies. With cyber attacks becoming increasingly sophisticated, a static approach to cybersecurity could leave military systems vulnerable. The significance here is in recognizing that cybersecurity must be an evolving discipline with continuous updates and training for personnel to defend against new and unforeseen cyber threats. This proactive approach is essential to maintaining operational readiness in the face of evolving cyber challenges. 5. Funding allocation transparency. The allocation of the $3.2 billion budget is mentioned, but the specific breakdown across the 4 phases and technologies is not detailed. Understanding how funds are allocated is crucial for accountability and effectiveness. The significance of transparency in funding allocation lies in its ability to foster trust among stakeholders, including government entities, military personnel, and taxpayers. Additionally, a transparent allocation process can lead to better decision-making and prioritization of resources in response to emerging threats or changing operational needs. 6. Human factors and training. The report does not adequately address the human factors involved in implementing advanced weaponry systems, particularly regarding training and adaptation of personnel to new technologies. As systems become more complex and automated, the human element remains critical for operational success. The significance of this oversight is profound, as inadequate training can lead to human error, mismanagement of resources, and the inability to fully leverage advanced capabilities. Ensuring that military personnel are equipped with the necessary skills and knowledge to operate new systems is vital for achieving the intended benefits of technological advancements. 7. Geopolitical implications. The strategic initiative's implications on global military dynamics are not explicitly discussed. The implementation of advanced weaponry systems by 2025 could shift the balance of power in various regions and provoke responses from other nations. This aspect is significant because understanding the geopolitical landscape is essential for anticipating reactions from allies and adversaries alike. Policymakers and military strategists must consider how advancements in military capabilities could influence international relations and defense postures, potentially leading to arms races or new alliances. 8. Environmental considerations. As military operations increasingly intersect with environmental concerns, the report neglects to address the environmental impact of new weaponry systems. The significance of incorporating sustainability into military planning is growing as nations face the realities of climate change and resource scarcity. Advanced weaponry systems that are environmentally conscious can enhance a nation's reputation and operational effectiveness while aligning military objectives with broader societal values. In summary, while the report provides a comprehensive overview of the implementation of advanced weaponry systems by 2025, it overlooks several critical aspects that could significantly impact the initiative's success. Addressing these overlooked points: long-term sustainability, interoperability challenges, emerging technologies, adaptive cybersecurity, funding transparency, human factors in training, geopolitical implications, and environmental considerations will be essential for achieving a robust and effective military capability that meets the demands of modern warfare. The implementation of advanced weaponry systems by 2025, with a budget allocation of $3.2 billion for cyber, air, and naval integration, is a complex and strategic endeavor. Here are the 4 most valuable points for in-depth analysis and discussion. 1. Research and development (R&D) focus on emerging technologies. The R&D phase is pivotal as it lays the groundwork for all subsequent actions. It emphasizes the importance of identifying technological needs and developing prototypes that incorporate cutting-edge technologies such as artificial intelligence, AI, machine learning, and advanced sensor technology. These technologies are not only crucial for enhancing decision-making but also for improving operational effectiveness. In-depth exploration of how these technologies can be integrated into weapon systems will reveal their potential impacts on military strategy, including AI in combat scenarios, the role AI can play in real-time decision-making and how it could change the dynamics of battlefield engagements. Machine learning for predictive maintenance, the implications of using machine learning algorithms to predict equipment failures and maintenance needs, potentially reducing downtime and increasing operational readiness. Sensor fusion, the significance of integrating various sensor data to create a comprehensive operational picture that could inform strategic military decisions. 2. Testing and evaluation as a critical validation mechanism. After R&D, the testing and evaluation phase is essential for assessing the performance and reliability of the new weapon systems. This phase involves rigorous simulations and field tests, which are critical for validating technologies in real-world scenarios. The analysis here can focus on importance of rigorous testing protocols, discussing the methodologies for testing advanced weaponry and the challenges associated with ensuring reliability under diverse conditions. Risk management, evaluating how testing outcomes inform risk assessments and influence decision-making in subsequent phases. Feedback loops, the necessity of creating feedback mechanisms from testing phases to R&D for iterative improvements enhancing system performance and reliability. 3. Integration and deployment challenges. The integration and deployment phase is where theoretical designs become practical applications. This stage not only involves technical compatibility with existing military platforms but also necessitates comprehensive training for personnel. Key points of analysis include interoperability across military branches, investigating how advanced weapon systems can achieve seamless operation across air, land, and sea forces, which is crucial for modern military operations. Cybersecurity integration, analyzing how cyber capabilities are integrated into weapon systems to protect against digital threats, and the implications of these threats on national security. Training and human factors, exploring the challenges of training personnel to operate new systems and the importance of human factors in system design and operation. 4. Operational readiness and maintenance protocols. Achieving operational readiness and establishing effective maintenance protocols is critical for ensuring that advanced weapon systems remain functional and effective against evolving threats. The discussion points here can include sustainment strategies, the development of maintenance strategies that ensure long-term viability and adaptability of advanced weaponry systems. Continuous monitoring and upgrades, the necessity of implementing systems for ongoing performance monitoring and regular upgrades to adapt to new threats and technological advancements. Impact on military doctrine, how operational readiness and the ability to adapt quickly can influence military strategy and doctrine in an increasingly fast-paced technological landscape. Conclusion. The implementation of advanced weaponry systems by 2025 represents a significant investment in military capabilities with a structured approach spanning R&D, testing, integration, and operational readiness. Each phase presents unique challenges and opportunities that warrant detailed analysis to understand their implications on future military operations and national security. By focusing on these 4 key points, stakeholders can ensure a more robust and effective military capability in the face of evolving global threats. 1. The Manhattan Project 1942–1946. The Manhattan Project was a research and development project during World War II that produced the first nuclear weapons. It involved significant investment and coordination of various scientific and military sectors. The project was divided into several phases, including research and development testing, notably the Trinity test and deployment of atomic bombs on Hiroshima and Nagasaki. The initiative was marked by its focus on advanced technology and the urgent need for a decisive military advantage. Similar to the contemporary emphasis on integrating advanced weaponry systems, 2. The Apollo Program 1961 to 1972. The Apollo program was a series of space missions undertaken by NASA with the goal of landing humans on the Moon and bringing them safely back to Earth. This initiative involved extensive research and development, rigorous testing of spacecraft, and the integration of various technologies including navigation, communication, and life support systems. The program's phases included the design and testing of the Saturn V rocket, the development of the lunar module, and the eventual deployment of astronauts to the Moon, showcasing a similar structured approach to achieving complex technological objectives within a defined budget and timeline. 3. The Strategic Defense Initiative 1983. Proposed by U.S. President Ronald Reagan, the Strategic Defense Initiative (SDI) aimed to develop a system that would protect the United States from incoming nuclear missiles through advanced technologies, including ground-based and space-based systems. The initiative was structured around multiple phases focusing on research and development of missile defense technologies, testing various systems, and ultimately integrating them into a cohesive defense strategy. This initiative, like the proposed advanced weaponry systems, underscored the importance of innovation, cybersecurity, and the need for interoperability among different military assets. Future outlook: implementation of advanced weaponry systems by 2025. The Strategic Initiative for Implementing Advanced Weaponry Systems by 2025, backed by a $3.2 billion budget for cyber, air, and naval integration, is poised to reshape military capabilities significantly. Based on the planned 4 key phases, several predictions can be made about the future of military technology and operational readiness. 1. Acceleration of technological advancements. By 2025, the military is likely to see rapid advancements in artificial intelligence, AI, machine learning, and sensor technologies. As R&D progresses, we can expect the emergence of sophisticated weaponry systems capable of autonomous decision-making, enhanced surveillance, and improved targeting accuracy. The focus on integrating AI into military systems will also lead to more agile and responsive operational strategies, enabling forces to adapt quickly to changing battlefield conditions. 2. Increased investment in cybersecurity. Given the emphasis on cybersecurity throughout the implementation phases, future military operations will place a heightened focus on protecting advanced weaponry from cyber threats. By 2025, military infrastructures will likely adopt more robust cybersecurity measures, including advanced encryption methods, intrusion detection systems, and regular cybersecurity drills. This investment will not only safeguard weapon systems but also ensure the integrity of communications and data sharing across military branches. 3. Enhanced interoperability among military branches. As the initiative prioritizes interoperability, we can anticipate that by 2025 air, naval, and ground forces will operate more cohesively than ever before. The integration of advanced systems will facilitate real-time data sharing and joint operations, leading to improved coordination during missions. This enhanced interoperability will allow for quicker response times and a more unified approach to national defense, particularly in joint multinational operations. 4. Shift toward autonomous systems and robotics. One notable trend will be the increased reliance on autonomous systems and robotics in military operations. Drones and unmanned systems will play a pivotal role in surveillance and combat, minimizing human risk while maximizing operational effectiveness. By 2025, we may witness advanced drone fleets capable of executing complex missions autonomously, thus reshaping strategies in air and naval warfare. 5. Evolving maintenance and support structures. With the implementation of advanced weaponry systems, maintenance protocols will evolve significantly. By 2025, predictive maintenance powered by AI and machine learning will likely become standard practice, allowing for real-time monitoring of system health and performance. This proactive approach will reduce downtime, optimize resource allocation, and extend the lifespan of advanced systems, contributing to overall operational readiness. 6. Geopolitical implications and defense strategies. The advancements in military capabilities by 2025 will also have significant geopolitical implications. Nations will likely respond to the increased capabilities of others by accelerating their own military modernization efforts. This arms race could lead to heightened tensions, particularly in regions where military balance is precarious. As a result, defense strategies will need to adapt, emphasizing deterrence and rapid response capabilities to counter emerging threats. 7. Collaboration with private sector and tech companies. The successful implementation of advanced weaponry systems will necessitate closer collaboration between military entities and private sector technology firms. By 2025, we can expect an increase in public-private partnerships aimed at fostering innovation and accelerating the development of cutting-edge technologies. This collaboration will not only enhance the capabilities of military systems but also drive technological advancements in the civilian sector. 8. Focus on ethical considerations and regulations. As military systems become more autonomous and reliant on AI, ethical considerations surrounding their use will gain prominence. By 2025, military organizations will need to establish clear regulations and guidelines regarding the deployment of advanced weaponry, particularly in terms of autonomous decision-making in combat scenarios. This focus on ethics will be essential to maintain accountability and public trust in military operations. Conclusion. The future outlook for the implementation of advanced weaponry systems by 2025 is characterized by rapid technological advancements, enhanced cybersecurity measures, and improved interoperability among military branches. As nations strive to modernize their defense capabilities, the integration of AI and autonomous systems will redefine military strategies and operations. However, with these advancements come ethical considerations and geopolitical implications that will require careful navigation. Overall, the successful execution of this initiative will significantly impact national defense and global security dynamics in the coming years.